Good. Right. So we finished indefinite integration, definite integration. Let's go. So when we started this whole topic, right? And we
Afternoon.
good evening. And we started indefinite integration. I told you that there's a difference between definite and indefinite integration, right? There's two types of integration. So what we did before, indefinite integration. How do you know it's indefinite integration? You saw the plus c. Every time you see that plus c, which is the arbitrary constant, you know that is indefinite integration. So what exactly is definite integration now? Well, definite integration of a function produces a value or number. So you see how when we are doing indefinite integration, you didn't get an exact value. So let me just go back for a bit. Just look here. Like when we were doing this, and we integrated the gradient function dy on dx is equal to 2x minus 3. When we integrated this, we got this. Y is equal to x squared minus 3x plus c. We got an equation. It's not the same for definite integration, right? So for indefinite integration, you got an equation like this with your plus c. For definite integration, now you're going to get an exact value or number. So you see when, I don't know, maybe I have a function. Okay, well, you would see, right? When you integrate a function using definite integration, you're going to get a value. So it might be 2, you might get a value of a half, 0.5. It's going to be a value, right? Unlike indefinite integration, where we got an equation for y. You see what I mean just now? And the value that you get is determined by the upper and lower limits of the integration. So this is the rule for definite integration, right? The integral of f inverse x is equal to f of b minus f of a. B is called the upper limit, hence it's on top here. A is the lower limit here. And then this right here, this is the differential of f of x. So why I put this in? Just note, you see this symbolism right here? It means the same as the gradient function, right? So instead of putting this, I could have put dy on dx. You see when you see that little, like that little dash thing there? It implies that you're doing, which one is easier? Wait, I'm not seeing that. What do you mean, like between definite and indefinite integration? I don't know. You see for yourself. Right. So you see when you see that little dash thing there, you may see it in textbook. So if you're looking online for something, let's say I have that dash g dash x. That just means the differential, right? dy and dx. That's what they mean. It's just another symbol to represent the differential of a function, right? So don't get surprised if you see this. It just means the differential dy and dx. So this represents the differential of f of x. So what exactly do I mean by the differential of f of x? Well, when I started this whole topic of integration, I told you that integration is an anti-differentiation process, meaning that integration is just the reverse of differentiation, right? So say I had an equation y, and I wanted to find the gradient function dy and dx, like I drew this when we started it, right? So say you have an equation y, and they want you to find the differential, you know you differentiate. So I have my arrow going down here. This is differentiation. Then when I was explaining integration, I said integration is the reverse of differentiation. So it goes from the gradient function back to y. That's the definition of integration, right? So now switching out the y and the dy and dx, and instead I'm putting f of x on this little symbol here. F of x to give me the differential of f of x. So going this way is differentiation, going this way is integration. I'm just showing you the different symbols that you might see, right? So please don't get confused. Do not panic if you see this symbol in your exam or in any other paper, right? It just means the differential. This, going from the original thing to the differential, and then from the differential back to the original thing, same thing here, right? Just different symbols. Do not panic. Okay. Everybody understand what I mean? What I'm trying to show you here? It's the same thing, just two different symbols. Do you get that? Yes? No? Yep. Yep. Okay. So don't panic. It's just different symbols. Right. So you might be wondering what happened to plus c. Notice here, I have nothing with plus c, right? Indefinite integration. When I integrated, I got whatever plus c. Here, you're not seeing any plus c. I integrated, okay, but I only see here f of b minus f of a. Where did my plus c go? What happened to plus c? Well, consider this. If I gave you this right here, right? This integral. So forgetting these limits for now. So let me show you what we're looking at right now. Forgetting the limits. Just pretend I gave you this. The integral of 9x squared dx. And I ask you to differentiate that. You would tell me using the rule. So assuming that this is forgetting all this for now, right? If I give you this right here, and I ask you to integrate 9x squared with respect to x, so applying your indefinite integration rules, right? You would tell me that this is 9x cubed on 3, oh my, no, don't give trouble, on 3 plus c. That's if you're doing indefinite integration, right? But of course, you won't leave it like this. You would reduce it to 3x cubed plus c. That's what I have here. F of x is equal to 3x cubed plus c. That's your indefinite integration. We know about that. So now applying these limits right here. So I see a 5 on top here. Functions, it's no longer on your ADMAS syllabus. Like from 2021 onwards, they took it out. But for math though, functions, it's still on your syllabus. So I'm hoping you know, if they told me the value of x is 5, this is my function f of x is defined by 3x cubed plus c. And then they told me x is equal to 5. So to find f of 5, what I need to do, wherever I see x in this function, I replace it with 5. So if f of x is equal to 3x cubed plus c, then f of 5 is equal to 5 cubed. All I did was replace the x with a 5 plus c. I simplify this, I get 375 plus c. If I then took this lower number here, so when x is equal to 2, then f of 2 is going to be 2 cubed. All I did was replace this x with 2, right? Functions. For those who did functions in math, this should be familiar. For those who didn't, as yet, you'll come to it eventually, right? So all I did, wherever I see x in this function here, I replace it with 2. That's what f of 2 would be, right? Wherever I see x in the function, I replace it with 2. So 2 cubed plus c, I simplify this, I get 24 plus c. According to my definite integration rule though, then I have to find what f of b minus f of a is. If I do that, b was 5, so f of 5 is this. A is 2, f of 2 is this. If I subtract these two now, so I subtract f of 5 minus f of 2, this is definite integration. That's the rule that we just saw. And I said 375 plus c, which was f of 5, minus 24 plus c, f of 2. When I simplify this, right, I'm going to end up with 375 plus c, right? But then this right here, this is basic algebra, right? This negative sign is going to be distributed evenly across this bracket here, right? So saying minus 24 plus c, this is in brackets, right? It's the same as saying minus 24 minus c. That's just algebra. These c's cancel, plus c minus c, they're going to cancel. And hence the only thing I remain with is 375 minus 24, which is 351. And that just goes to show you, with definite integration, the c's would cancel because plus c minus c, they would cancel each other out. Do you understand that? Or would you like me to explain it again? So in indefinite integration, we solve for limits, subtraction accordingly, and this, yep, that's it. You can't go on this, okay. Josh, you're correct, right? That's definite integration. So glad you understand. Oops, somebody should. Yeah, it is easy. All right. Just some rules that you need to know. Some rules special to definite integration. So this first rule, just like when you saw when we were doing indefinite integration, where you take the constant out, so the integral of c by the differential of f of x dx is the same as saying c multiplied by the differential. Same thing, right? This is another rule you need to know. Notice here. So look up here first, right? B is my upper limit, A is my lower limit. But let's say for some reason the limits are switched. So instead I have my lower limit on top and my upper limit below. For whatever reason, that's the same as saying minus the integral of this, right? The original thing. But this, if you ever see a question like this, don't worry, I've never seen a question like this in any of the papers. But you still need to know it, right? If you get a range like this, f is less than, well, let me not say it like that. C is greater than or equal to A, but less than or equal to B. It can be represented like this, okay? Just know the rules, but I'm telling you, see these two? For your exam, never seen a question that requires you to apply these two rules, but still learn it just in case. You never know. This one, we basically met this when we were doing indefinite integration. Just take out the constant, integrate like normal, and then multiply your answer by the constant, right? You'll see what I mean just now when we practice. Anybody has any questions about any of these?
No, miss.
Okay. Oh, and note, you see, like, okay, let me just go back real quick. This PowerPoint is so long. So you see, like, rules like these, given sums and differences, you still have to integrate each term separately. That still applies for definite integration. Okay, so don't forget that. when integrating the trigs, it's still this rule, just leave out the plus c. And like I said, with the constant, you're still pulling out the constant, integrating like normal, then multiplying your answer by the constant, right? So just follow the rules and you get to it. Okay, let's practice this. Okay. Write down the first one for me, and we'll do it together. Let me know when you're done. Practice. Can I move on now? Fine. This screen? Yeah? No? Then once. Go twice. Okay. Well, how do we go about doing this? Like I said, integration is all about the rules. Follow the rules, you're good to go. And of course, understand why you're doing it, right? Okay. So what's the question? The question asks you to differentiate this. Notice, you see, because I have an upper and a lower limit, the upper limit is the number on top here, the lower limit is the number to the bottom. Because I see these limits, I know it's definite integration and I do not need the plus c. So that's how you would be able to tell whether you're doing definite or indefinite integration. If you have definite integration, you have limits. So you see a number on top and a number below. If you don't see any numbers, then it's indefinite integration. So don't forget your plus c. All right, let's continue. So they want you to integrate this right here, 2x minus 3 with respect to x. And then they told you the upper limit is 1, lower limit is minus 1. So the first thing you want to do when dealing with definite integration, do as you did before. Just integrate the expression here. So the first thing you're doing, integrate like normal. What do I mean by like normal? Apply the rule, the basic integration rule, right? Which states the integral of ax to the n with respect to x is going to be equal to ax n plus 1 all on n plus 1. No plus c, because this is definite integration, not indefinite integration. So the first thing you're doing, just apply this rule, the basic rule of integration, so that you can integrate this expression right here. So first step, that's what we're doing. We integrate it. What will we get? If I apply the rule here, I'm going to get 2x squared on 2. That's just me following this rule, right? Minus 3x on 1. No plus c. You see when you're doing definite integration, after you integrate the expression, you're going to put a bracket here, put your upper limit on top, your lower limit below. That's just the standard way how to write it, right? So you're integrating this, the expression, using the rule you know. So we already know that. We integrating this, put the bracket, upper limit, lower limit. So this is really the only new thing right here, right? Everybody following that so far? Definite integration must always have limits. Yes. Once you see limits, it's definite integration. Everybody understand what I did here? The only new thing is this bracket here. You know how to do this. Do you understand? Yes? No?
Yeah.
But you don't leave it like this, right? Because you can simplify that even more. Cancel 2. X squared minus 3x on 1 is the same as saying 3x, right? 3x. Put your bracket. Upper limit is 1 minus 1. By definition, must have limit. Yes, must have limit. So, now that you have this, the next thing you do, apply the rule. It's all about the rules. All about the rules. So the integral upper limit b a, and this is equal to f of b minus f of a. Applying this rule, the f of b minus f of a, what I'm going to write now, b in this case is 1, and my function is x squared minus 3x. So following this rule, f of b, wherever wherever I see x in this expression here, I'm going to replace it with 1. Squared minus 3 by 1. Let me use the square bracket. So this is my f of b, right? Minus f of a. I'm going to replace these x's with minus 1. And all you do now, subtraction. Simplify and subtract. 1 squared minus 3, that's minus 2, minus 2. Okay, let me write it out. Do you understand what I did here with the green? Yes, no? Yes.
Yes, ma'am.
Where's Troy? Troy. Who else? Who else is here?
Huh? What is it?
Troy, you good?
I'm following.
Okay. Who else? Micaiah, you good?
Yes, I'm just gonna custom it.
Okay. Jana, you good?
Yes, miss.
Wait. Let me write it out.
I'm not going to erase it. So continue from the green part. All they do
Yeah.
is simplify now. 1 squared minus 3, that's minus 2, minus 1 squared is 1, minus 3, so that's, let's see, that's 4. And this is going to give me minus 6. That's the answer. And that is what I meant by definite integration gives you a number. A number. I'm going to wait for the clock. Okay. I think Josh would appreciate that. He's always complaining that you're going too quickly. Everybody good with this?
Yes, miss.
Okay. Can I clear it now?
Yes, miss.
Okay. Going once, going twice. Clear. Okay. Would you like, oh, yes, no. Try this, please. The second one. So the first thing you need to do, integrate. So just temperate, okay, hold on. Yeah. For a minute, just forget about everything else. Focus on integrating this thing right here. That's what I want you to do. Just forget everything for a bit. Integrate it using the rule that you know. How exactly do we integrate that? X by x squared minus 2 is a problem. Why? This isn't in a form that I can integrate. According to my rule, so the basic rule of integration is this ax to the n plus 1 all on n plus 1. This is not in the form ax to the n. Okay, I have less than a minute. Rejoin.